So firstly I have to import the data into Excel. So I click from text, import the PSI readings over, just click next. However, for this part you have to change the format from overall PSI reading format from general to text. And click finish. It will show all the values that you want. So to compare which region have the best air quality and the worst air quality, you have to go to data analysis, descriptive statistics, and click the region that you want to find, and click the output range. Click OK. So it will show the readings that you want to find for region North. So after finding all the other regions, you compare the means. So East have the lowest mean. We mean the East region have the best air quality, while the West have the highest mean, which means that the region has the worst air quality. So after knowing West is the worst air quality, you just have to go to Insert, Pivot Chart. Just put the data date against the PSI of West. However, the question wants the maximum of West, so you have to change it from count to West. So in order to make the graph able to see the readings per day, you have to extend the graph so it's really more clearer. For question 2, they want to find the average of the 5 months. So I just have to click the date and plot it against all the other regions. And I also have to change the summarized values from count to average, and it will show the values of all the average of per day. So having this data, I can calculate out the confidence interval. So in order to get the total, I have to click the formula, which is equals sum, and plot in all the data that I want. So it's all of there. Then for standard deviation is also stdev.s, as in it's for sampling. So click all the data again, and you'll get all the data, and the end value previously I find it is 153, as it's the total days from June to October. So the point estimate, you do the same thing, equal average, and click all the total value into, click all the input into the data. So for standard error, I just have to take the standard deviation square root of n. So the formula for square root is SQRT. So you show the values that you want. And for alpha, you have to use a special formula which is norm s dot invert, and this time the value is 0.95, so you will get 1644854. So for sampling error, you just have to take standard error times alpha over divided by 2. So for the lower and upper limit, you just have to take the mean plus minus sampling error, and you get all the data. So for the second part of question 2, you have to find the PSI that exceed 30. So you have to change all the value into maximum so that you can find what is more, which day is the month more than 30. So I can use the formula count if as, then record the data from July and August. So you do from July to August. So after importing the data, you have to highlight more than 30, comma. So let's do it for all the regions. Okay. So you get 13. So you have to just do the same for September, October. So all the formula are the same. So next you have to plot the table, the steps to find the hypothesis. So you have to state the level of significance is 0.01, and the PSI is a compare proportion from July, August, and September and October. So as you know, the PSI rating we just find is 13. So the total day of July and August is 62. So 13 over 62, you will get a value. So the size is 62. So for this you do the same thing. September and October is 61, and use the value more than 30 is 11. So 11 over 61, you get a proportion amount. So the null hypothesis is that the PS1, which is July and August, is not equal to PS2 of September and October. So the alternate hypothesis is not equal, and the null is equal. So in order to prove it, you have to find the critical value, which is the lower z value by clicking norm s dot inverse 0.005 as the Excel read the graph from the left. So we do it for the same thing for the upper z value, and use 0.995 to get the upper value. So the statistic, you just have to input the formula from B2, the PSI minus the PS2, and square root over the B2 1 minus the PSI, and B3, which is the size, and plus the formula of test statistic. Then after finding is negative 2.31, you state that since it is more than the lower z value and less than the upper z value, it does not lie in the rejection region. So therefore we do not have sufficient evidence to reject the null hypothesis at 1% level of significance.